Now we're going to return to the last of the case studies of English syntax that we've looked at in the last several cases. Now we're going to return to our last case study of English syntax that we've looked at in the last several lectures. This was a case where not even the weak generative capacity of finite state models was adequate for capturing what strings were and weren't in the language. This is the case of nested object extracted relative clauses. And the pattern is instantiated by this sequence of sentences. We start off with, the rock can be found in the garden. Now, at the point of the end of the word rock, we can insert what's called a relative clause, and we can get the rock that the squirrel likes, so that the squirrel likes is a certain kind of relative clause modifying the word rock. We can then, and that's a perfectly grammatical sentence. They start to get more difficult when we do this time and time again. So I can take once again at the word squirrel. Any noun can have a relative clause modifying it. So the squirrel that the dog chases is a relative clause modifying the squirrel, and that's fine. It starts to get difficult to understand in context, but once again, this is a sequence that's justified by the grammatical rule of object extracted relative clause formation. So we have the rock that the squirrel that the dog chases likes can be found in the garden, and we can do this again and again. For example, the rock that the squirrel that the dog that the woman owns chases likes can be found in the garden. And these become very, very difficult to understand, but as we've discussed earlier, it's theoretically productive to take this infinite sequence of sentences instantiated by this beginning, this set of four, as being characteristic of the syntactic structures that are afforded by natural language. Note that this pattern involves what we might call n to the I, v to the I matched pair nouns and verbs. So I've color-coded, in fact, the matching nouns and the verbs that they are the subject of. And that n to the I, v to the I pattern was enough to make these examples outside of the weak generative capacity of finite state models, because as you may recall, finite state models cannot handle that arbitrary matching pair problem. Now, there's an insight into understanding the syntax of these examples, which is the following. And this is a little different than the previous cases that we looked at. The extraction property of relative clauses implies that certain phrasal categories inside them behave in exactly the ordinary way, except that they're quote-unquote missing an element. So what I mean by missing an element is, for example, the rock that the squirrel likes. So the squirrel likes is an ordinary kind of syntactic phrase. In particular, it's a clause, the same way as the rock can be found in the garden is, but it's missing an element, in particular the object of likes. And the missing an element property seems to be formally responsible for the structure of the grammar. And in fact, this will have to be the case in order for the grammar not to do what we call overgenerate, which is to make possible structures that are actually not okay in the language. And let me instantiate this a little more in specificity. So let's take the following context-free grammar. And I'm omitting some of the terminal rewrites, like what are the words that can instantiate determiner, noun, and verb, for example. And but it's a simple grammar, and RC is the category for relative clause, and it says that a relative clause is formed of the word that and then an S category, and an S category is an ordinary clause. And you can go back and look and remember that an S is a noun phrase and a verb phrase, and we know already the noun phrase and verb phrase are familiar. Okay, so this actually does the right things in terms of licensing, generating the required structures for object extracted relative clauses. So I can apply all these rules that we have here, and I can get a structure like you see below. The rock that the squirrel likes can be found in the garden. I've omitted the prepositional phrase rule, but you're already familiar with the prepositional phrase rule. Okay, so this structure is perfectly fine. However, there's a problem in that it admits structures that are not acceptable. So, and that's what's called overgenerating. It allows cases like the below, where the missing an element property of the relative clause is broken by the appearance of something in its stead. So here the sentence is, the rock that the squirrel likes the tree can be found in the garden. And you probably hear, if you're a native speaker, certainly, and even if you're a non-native speaker, this probably sounds off to you. And the reason is that there's this element, the tree, which is a noun phrase, which is in a perfectly normal place for it to be outside of context. In particular, the clause, the squirrel likes the tree, taken by itself would be a perfectly natural structure. But in this particular context, it's not okay. And the reason is that the broader context in which that S category occurs says that I need to have something that would ordinarily be there missing. And the thing that is the problem here is that the tree is where the thing that should be missing would have been. And that creates a problem. And so thus we have designated this sentence as ungrammatical. Now, this is more general than just relative clauses. So another type of example about element missings are what do we call WH questions. Questions that are formed by words like who, what, where, when, why, how. In particular, who or what are extremely easy to see in these cases. And so what I'm going to show you here below is this examples of this missing an element property. And this underscore right here that I have here, this is conventional in generative linguistics to denote an empty string that would have to have something there, except that there's a special environment that the phrase of the empty string occurs in, which is which makes it not needed in general, not even possible. So let's look at some examples like this. Who did Kim invite to the party? Perfectly natural sounding sentence. Notice that if I got rid of the who did and I added the D to invite, Kim invited to the party and made it a period, that would sound off. Okay, so I would put a star around that because it's missing an object. Kim invited to the party. Who did Kim invite? We don't know. So ordinarily, invite requires an object in the position immediately after it. That's a characteristic of English syntax. But in this case, it's perfectly fine. And the reason is the word who serves that role of the word invites object. We can contrast that with, in fact, if we made that phrase explicit, it would actually render the sentence unacceptable. Who did Kim invite the neighbors to the party? Now it feels like that something's wrong because the neighbors doesn't belong anymore because who is there? Likewise, and now I'm going to show you is that this actually holds even when more intervening material is interposed between the WH phrase and the place where the element can't be. So who did you say invited you to the party? That's also perfectly fine. And if I add an explicit subject, now notice this is an extracted subject position now. It's who's doing the inviting. If I make that explicit, it becomes unacceptable once again. Who did you say the neighbors invited you to the party? It's off. Okay. And this is actually even more general. And one thing I'll note is that this actually is not just a sequence of words. This is a level of clausal embedding. So there's actually tree structural depth in here, and we're going to get to that in a moment. So if I go in 5 through 8, I've added more and more of that tree structural depth. Who did you say? What did you say you ate at the party? What did you say you ate food at the party? Not okay. How about this? What did you say Kim told you that Pat ate at the party? This whole chain of verbs, and the relationship is actually a nesting relationship. That's okay. If I put the word food there explicitly, it becomes bad. What did you say Kim told you that Pat ate food at the party is not okay. So once again, this missing element property, which we saw in relative clauses, we're also seeing in WH questions. And this is what's called extraction. The element has been extracted from its ordinary environment, which is indicated by the underscore, and actually can't be there in English. And extraction, crucially, is what's called an unbounded depth dependency. It can span an unbounded number of levels of clausal embedding. So once again, a sequence first with WH and second with relative clauses will do. Who did Kim invite to the party? Perfectly fine. I can add you say, and now Kim invite is a new level of clausal embedding. Who did you say Kim invited to the party? I can do this again. Who did you say Pat suspected Kim invited to the party? Should be a bracket here. Who did you say Terry texted that Pat suspected Kim invited to the party? Also okay. We can continue with this. Here is the example in relative clauses. This is the person that Kim invited to the party. I can add another level here. This is the person that you said Kim invited to the party. This is the person that you said Pat suspected Kim invited to the party. this is the person that you said Terry texted that Pat suspected Kim invited to the party. All of these are okay. Now, crucially, I'm going to show you again that as with before, the problem with ordinary phrase structure representations that we've looked at so far is that it effectively fails to remember this chain of extraction property. So I have a little grammar of the relative clause cases up here, and this is going to be a case that's not okay. Okay, so I've added this to illustrate the clausal embedding. I've added this complement clause thing. So a verb phrase can rewrite as a verb and a complement clause. We're going to call this sometimes S bar later on. You'll see that as well. And a complement clause optionally starts with the word that and then is an ordinary sentence. And as you know before, a relative clause seemingly is the word that followed by another sentence. And this will generate the this sentence that I've got here is, okay, this is the person you said Kim invited to the party. But the problem is that the simple categories in the grammar above fail to remember that there is an extraction once we are inside the relative clause. And so notice that the rule here says that, and this is a perfectly well-justified rule, a verb phrase can consist of a verb, a noun phrase, and a prepositional phrase. And the noun phrase can be optional. And that's what licenses this little bit of structure right here. But because it could also have a noun phrase, I could also add a noun phrase. And I could, and this little triangle is going to say I'm not going to bother to write out the rest of the structure. For example, I could put in the word me. This is the person you said, this is the person that you said Kim invited me to the party. That is off. It's not clear where the person's role is anymore inside all of this structure. And the problem here is that, so this is not okay. But the thing that makes it not okay is way up here. And so the problem is we need to propagate information downward into the tree, or back upward into the tree, depending on the way you look at it, to make sure that the property of being inside a relative clause like this, which is an extracted environment, is respected down here. But the way that I've represented the tree fragment here, it does not actually respect that. And so the problem here is that this representation of a chain of categories like this does not capture the dependency that we care about. Okay, so the problem is that the grammar would not roll out adding an object noun phrase after invited like it should. So the grammar actually should rule that possibility out, but it fails to do so. Now, these unbounded dependency constructions were actually crucial in the history of generative grammar at the very beginning. They were a part, although not all of the motivation, that was originally given in the first papers published on generative grammar. Chomsky 1956 is the one I would refer you to, for what was called then a transformational grammar that went beyond the expressive capabilities of context-free grammars. And actually, if you look at the entire history of contemporary generative grammar, these undependent dependencies play a crucial role, and they were motivating in a very important way for the kind of grammatical formalisms that were of interest. And in fact, actually, these motivated a step away from context-free grammars to more expressive representational systems. However, it turns out that we actually can incorporate long-distance dependency constraints within the context-free grammar formalism, and we can avoid this kind of overgeneration. It took a long time for researchers to figure this out, and it was first shown around the beginning of the 80s by Gazdar and others. And what we're going to get to next is a theoretical innovation associated with the formalism that's called generalized phrase structure grammar to introduce meta rules that state implicational relationships between the presence of certain types of categories and rules and other kinds of categories and rules. This will keep us within the context-free grammar formalism, but it will allow us to model these unbounded dependency constructions. And generalized phrase structure grammar is not widely practiced anymore today, but the insight, I think, is sort of important, and actually in fact shows up in all of the contemporary grammatical formalisms that are used these days in modeling syntax. So this insight of some way of propagating information through different parts of a tree structure is going to be crucial. So we'll pause now, and then we'll continue in just a moment by looking at this meta rule mechanism for propagating information appropriately in unbounded dependency constructions.